Okay, so 6.2. We're going to be dealing with slopes perpendicular and parallel lines. So when I say parallel lines, does everyone know what I'm talking about there?
Yeah.
Yeah.
Same.
That's right. There's two lines that will never touch, right?
Like they're the same though.
Well, they're pretty much the same, yeah. Think about like railroad tracks, right? They're never going to touch. When I say perpendicular, do you guys understand what I mean? No, kind of, maybe. When they intersect, but they cross at 90 degrees. Okay? And we use this symbol here. It's like an upside down T. Okay? And we use that because they form a right angle. Okay, so we're going to be looking at these lines today. Okay, because what's unique about them is because they cross exactly 90 degrees or because they never touch, their slopes are very unique. Okay? So if we look at parallel lines, we'll start there because they're kind of the easiest of the two.
Wait, with those parallel.
They don't touch. Parallel lines never touch. Okay. And this is because what's wrong there? Because their slopes are the exact same. Okay? So in dealing with slopes, sometimes we use the symbol. Remember when we talked about y equals mx plus b? M is the symbol for slope. I don't know why it's M. It just is. Okay, it's not S. I don't know why. So all you do is you'd say that the slope, you put a little 1 there for line 1, equals the slope of line 2. What's up?
M equals slope.
Yeah. M is the symbol for slope. Okay. So there's one line. So So this goes through 1 and 1. This one goes through -1 and 1. These two have identical slopes, okay? I go, my rise is 1, my run is 1. Rise is 1, run is 1. Lots of 1s on there. Okay? So that's what that looks like, okay? Another way you could show this is if you have equations. Like let's say, you know what? Put this below. This is another example. Like let's say you have one equation, y equals 3/2x plus 3. And then you also have another equation where it says y equals 3/2x minus 1,000. Are these two lines parallel? Why not, Chloe? Don't know?
Yes.
You just said both answers.
So one of them's right.
But also the other one's wrong. Say that again, Julia? I couldn't. No? Okay.
Say yes or no.
Well, yeah, what is it, guys?
No. It's yes.
It's yes. Look at it. My slopes are both the same, right? Remember now? Y equals mx plus b. M is
Wait,
slope.
yes, what? Yes.
The slopes are the same, so they are parallel. Okay? These numbers here, do you guys remember what the b stands for in y equals mx plus b? The y-intercept. Very good. So this one just has the line running through 3. This one just runs down at -1,000. But the slopes are the exact same. Okay? They're going to look completely different. Exact same, though, parallel. Okay? You just look at the number in front of x, and that tells you what's going on. Right.
Okay, wait, you look at
Yes.
the number before x.
Yes. Okay, let's try another example now. Example 2. Line AB passes through point A. I'm going to give you a coordinate for A. -4 and 2. And B, which is at 2, -1. Okay. Line CD, that's going to pass through.
Oh, what?
What? Just
Oh, it's just a dot?
where?
Like it's and then next one.
Sure. There.
That's not right.
I don't know.
Yeah.
This here?
CD.
CD.
It looks like a one in black.
Anyway, passes through point C, which is at -1 and 7, and D, which is at 7, 3. RAB and CD parallel. So you got two options. You could draw everything out and look at it and count the rise over the run, which would take a long time. Or we could use the slope formula that we learned yesterday.
Parallel?
Yeah, that's what that symbol stands for. Okay? So let's check the slope of AB first. MAB, or MAB. So I had 2 points. -4 and 2 and 2 and -1. It doesn't matter which one you pick to be y1 x or x1 y1 and x2 y2 as long as you're consistent. This one's first, so that's going to be number 1. This one's second, so that's my number 2. Okay? You could win 2 and 1. I don't care. You'll get the same answer regardless. Okay? So now you just plug everything in. So y2 is -1 minus 2. So that's y2. So this is x2. So it's going to be 2 minus -4. -1 take away 2. -3. 2 take away -4. It's +6. Yeah, -1/2. Good. So now I have to do the same for line CD. I'm going to pick point C to be x1, y1, D to be y1 or y2, x2. So it's going to be 3 minus -1 all over 7. Oh wait. Yeah, I put it backwards. 3 minus 7 all over 7. Take away -1. There we go. That's much better. 3 take away 7 is -4. 7 take away -1. Boom. Are they parallel? Yes. Right? Not so bad. You just figure them out. You just got to see if they're the exact same. Okay? Now we'll do perpendicular lines. Perpendicular lines, they're fun too. All right, perpendicular lines, their slopes, unfortunately, aren't identical. Because they intersect exactly 90 degrees, they're pretty much exact opposites of each other. Okay? Perpendicular lines. Their slopes. Okay. Write this down and then I can show you guys. They're just called negative reciprocals of one another. So by being the negative of something else, you just change the sign of it. So one number is 2, the negative of that is negative 2. Negative 500, the negative of that is positive 500. Okay? Now reciprocal, if you guys have heard that term, do you guys remember what it means? If I was to say when you're dividing fractions, you multiply by the reciprocal of the second term. Anything? Opposite. You. What?
I don't know.
Okay, I thought you had it. Never mind. It's fine. The reciprocal is that you flip the number. So the reciprocal of 2 over 3 is 3 over 2. So all you do is whatever slope you have, you flip that number and change the sign. Okay? So you just flip it and change the sign. Okay? So the negative reciprocal of 4 over 5 would be negative 5 over 4. Or, another example, the reciprocal of negative 2 would be positive 1/2. Technically, any whole number is just itself over 1. Okay? So that's all you got to do. You just check to see if they're the same or if they're flipped.
3 would be 1 over negative 3?
Yeah.
Or is it negative 1 over negative?
No, it'd just be negative 1 over 3. Like this, if you had 3, you would just write it as negative 1 over 3. Technically, Chloe, this negative, you only need 1 for the fraction. It can go on the top, on the bottom, or out front of everything. They're all the same. Okay? Any other questions? This is good stuff. All right. Cool. So, first example. So y equals and are those reciprocals of each other? Yeah. Look at the slope. I flipped them, and I changed the sign, didn't I? Negative reciprocals. So you know that they're going to meet at 90 degrees. Okay? So this positive one travels up, the negative one goes down. Does that, 90 degrees. Okay? Making sense so far? Awesome. I'm not going to do another example quite like the last one, where you just take the slopes and check them. Can you guys handle that? Okay. Let's try another example. What is the slope of a line perpendicular to the line passes through two and three and So I'm looking for a line that's going to be perpendicular to this one. Okay? So what have I been given here? I got 2 points. What can you typically do with 2 points?
Line X.
Line X. What'd you say, Maddie? Can't hear you. Rate of change. Yeah, you can find the slope. Okay, so let's find the slope, because we can find the slope of this line here, right? That passes through these 2 points. So once you find that slope, can we find a line that'll be perpendicular to that, the slope of that line? For sure. So let's try that. You guys try to solve the line here. Get the slope.
What are we doing?
Find the slope of this line here that passes through 2, 3, and negative 4, negative 1.
But how? Which way?
With the slope formula. Y2 minus y1 over x2 minus x. Sure. To take away negative. And it should be 3 take away negative 1.
On the top.
Yeah. 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 4 over 6. 2 over 3. Right? Take 2 out of everything. So now I want a line that's going to be perpendicular to this one. So what's the negative reciprocal of 2 over 3? 3 over 2. Negative, right? So what we do sometimes is we put that little t upside down t beside the slope to symbolize that it's perpendicular slope. Okay? So just people tend to remember to flip, no problem. But switching the sign can be tricky. Any questions? Okay, good. Last one. Give me a second to draw this one out. Don't draw anything just yet until I get this right. Sure you can. I can do whatever I want. Alright, let's try this again. Close. Those lines touch at that dot. Okay, so take this down now. What's that? Oh, I could, sure. So we want to know, is this geometric shape on this Cartesian plane, is it a rectangle? So is it a rectangle? Now the easiest way to do that is to show that one of the angles here will be 90 degrees. Because if, like, let's say this one here is 90 degrees, then that means the one across from it has to be 90. And if those two are 90, then the other two have to be 90 as well. All right, so all we need to prove here is that this guy, or any one of them, is 90 degrees. And by that, you show that they are perpendicular. Okay, so I picked this one here. So we'll do that. So we'll compare the slope of this line here. We'll call this line 1. We'll compare that to line 2. Okay? So we'll calculate the slope for line 1. M1. That's going to be, was it negative 4 and 2? So that's going to be 2, negative 4. And then it was at 4 and 4, minus 4, minus 4. And 2, 0 and 5, minus 4. Huh? Yeah, you're going to solve it. I'm just writing them both out. 0 take away 4. I just wrote them both out, Chloe, so because I don't want to scroll up and down. So M1, 2 take away 4 is negative 2. All over negative 8. Negative 8. Negative 2 and negative 8, the negatives both cancel though. Right, it's 1 over 4. Like negative 4 take away 4 is negative 8. Yeah, like the negative 2 and the negative 8.
2 negative, negative 5.
No, it has to look like this, Chloe. Negative 4 take away negative 4. But since it was negative 4 take away positive 4. Yeah. That one's 1 over 4. This guy here. Negative 4 over 1. So these are flipped and they're opposite signs, negative reciprocals. So yes, it is. Okay? Any questions about this? Basically more just slope formula, and then you're checking stuff. People tend to be really good at spotting parallel lines because those are the same. Done. This part here trips people up. Okay. Also know this: negative 2. Like if you have something like this, If you're looking at one slope's -2 and one slope's 2, are those identical? No, they're not. Okay? One's negative, one's positive, so they're not parallel. Okay, it's another common mistake that people make. If the signs aren't the same, then they're not parallel lines. Because a negative slope goes down, positive slope goes up, so those lines will totally touch. Okay? Any other questions?
If the signs aren't the same, they're not what?
If the signs aren't the same, then they're not parallel. Okay? All right, so on page 349, 3, 4. Nine. Very close.
Oh, right here.
Oh, perfect. Awesome. Oh, look at that. It's like 1:45 already.
Shall we just practice them up on the board? No.
No, get away from me. I don't, whatever reason, I feel like I'm always, with this one, I'm blocking it all the time. Yeah. It must be, it's really close up and pointed down more.
Well, not really on.
Yeah, there's also that. I don't know. I'm not going to be a hero and try to fix this. That should be good. What the heck?
You just pick up these lines and look at them.
No, like I know like stuff that I've added and stuff that I didn't already. I like gauge the time too. Like the goal is like if you buckle down, you should get this done in class. Or yeah.
Okay, yesterday I did it.
Ooh.
And then I did the assignment.
Well, that's good.
I get my water.